parallel combinations. In series combination, which bulb will give more brightness? Less wattage bulb will give more brightness. And what is the equivalent power in that? P series is equals to what is the formula? P series is equals to what is the formula? P1 P2 by P1 plus P2. Otherwise 1 by P series is equals to 1 by P1 plus 1 by P2. Low wattage gives you more brightness, otherwise more power consumption will be there in the low wattage bulb. Now whenever you go to the parallel combination, at that time high wattage bulb will have high brightness. Whichever the bulb is bulb is having more wattage, that will have more brightness or more power consumption. So in that, what is the equivalent power? Do you remember that? P equivalent is equals to what is the formula? Just P1 plus P2. Here wattage is, otherwise rated power is more. At that time what happens? Nothing but the brightness also more, otherwise power consumption also more here. Whenever the power rating is here less, then only the power consumption will be more in the case of series combination. And based on that we have done some problems also. Even we got some relations also. In that, one of the important relation is the power consumption is equals to what I can write? VA by VS whole square into PS. What is the VA here? Applied voltage. VS is specified voltage or rated voltage whole square into PS is nothing but what? Specified power, otherwise power rated on the bulb. So this is what we have discussed yesterday about the power concept. Now we will discuss about the measuring devices. One of the measuring devices is first of all Wheatstone bridge. In that Wheatstone bridge we no need to do any calculations and all, only balancing condition you have to get to know. That balancing condition I will tell you. If it is unbalanced, if the bridge is unbalanced, at that time the problem you have to solve either by the KVL. If you take the KVL, you have to take 4 equations to solve the equations, and then otherwise you can take the nodal method. That will be easy to find out the currents. Why? Because resistances they will give. Always they will give the resistances and ask the current, otherwise equivalent resistance. And very shortcut method is there for the equivalent resistance. I will tell you that also. In the case of unbalanced will not come, but we will not take a choice, so that current electricity is very important. Each and every topic we have to study in that. So only power I have took that much of time, and then I thoroughly explained the power, and then without any confusion also. Have you solved that problem yesterday? I have given, I think 4 to 5 problems I have given. Have you solved? Did you get the answers? Yes. So, and after that this Wheatstone bridge balanced and then unbalanced conditions are there, that we will discuss. Based on that we will do some problems. Up to Wheatstone bridge your weekend syllabus is there, up to Wheatstone bridge. And then after that we will discuss the meter bridge. Meter bridge will be very easy, but problems will be little confusing. You have to take the proper values for the problems. That meter bridge will be finished. After that potentiometer, and then this one ammeter, and then voltmeter we will discuss. And now let us discuss about the Wheatstone bridge. Wheatstone bridge. Wheatstone bridge. So here in the Wheatstone bridge there will be 5 resistors. 4 or 5? 5 will be there. Even the galvanometer will also have some resistance. Let us consider that is G. Galvanometer is there, no? In middle galvanometer is there. What is the purpose of galvanometer? To measure the currents. But ammeter also there, no? The galvanometer measures the smaller currents than ammeter. Ammeter can measure only up to this one only 0.1 ampere like that, but the galvanometer can measure up to the milliamperes also. So that here I have connected the galvanometer in middle. This will measure the current through the bridge, and also here this galvanometer will have a resistance of G, and then the current measuring in this is Ig, let us consider. Now what happens means, whenever I have connected the voltage here there will be a potential difference. This is V means, can I say this is V and then this is 0? Yes. If this is V means, can I say this is also V only? If this is 0 means, can I say this is also 0 only? Yes. So later on we will see by the unbalanced conditions and all. Now before that, here this is and all not necessary. Now here I have taken 4 resistors, along with that I have taken a galvanometer to measure the current. Even the galvanometer also having some resistance, that is how much, nothing but that is G. Now when the bridge is balanced, whenever the bridge is balanced means, at that time the potential difference between B and D is 0, nothing but the potential of B is exactly equals to the potential of D. Here whatever the potential is there, whatever the voltage is there, here the voltage both will be same only. If the potentials are same means, can I say that there will be a 0 current flow? What is the reason? Whenever the difference of potential is there, then only current will flow. Current will flow from where to where? Higher potential to lower potential. So where there is a potential difference, there is a current flow. Now here I am saying that whenever the bridge is balanced, the condition of the balancing is nothing but the potential of point B is exactly equals to potential of point D. Now here there is no current flow in this particular whatever we have taken. Then what I can say, nothing but the current whatever the I was coming here, that I is splitted as I1 and then I2 here. Now whenever there is no current flow, nothing but there is no need to take this one. Yes, if the current is not going, nothing but what is the use of that one? There is no usage of that. Now here current is I1 means, can I say here also I1 only? Both are in series combination, right? Then here this is I2 means, can I say this is also I2 only? I1 and then I2. Here current is coming like this and then just passing like this. It is not splitting at the branch. Why it is not splitting at the branch? Nothing but there is no potential difference only. If it is having a higher potential, it is having lower potential means current will split here and then it will come in the downward direction. Otherwise it is having the lower potential, it is having higher potential, nothing but the current I2 will split here, it will go in the upward direction. Always it will flow from higher potential to lower potential only. I said that both are having same potentials, there is no difference. There is no difference of height. Then how the water will flow? Water will not flow. It will not get splitted. So in the same way, here also whatever the current came here, that current directly gone here and then this current also directly gone here. Both are combining here. How much current will come again? I only. So from I1, I2 are splitting and then they are combining here and then they are coming as again I only. Now whenever the currents are going like this, these two are in which combination here? Series combination. And these two are also in which combination? Series combination. So equivalent resistance, I want to calculate the equivalent resistance. R equivalent is equals to what I can write? First of all, upper resistance, that is how much here? P plus Q. And then lower resistance is how much? R plus S. So what I can say, equivalent nothing but these two are, and again which combination? Parallel combination. P plus Q has a one resistor, R plus S has another resistance. Both are having in parallel combination. So what I can write here? R1 plus R1 into R2 by R1 plus R2. So R1 is how much here? P plus Q. R2 is how much? R plus S. So that P plus Q into R plus S by P plus Q plus R plus S. R1 into R2 by R1 plus R2 only I have written. That is the equivalent resistance whenever the bridge is balanced. And also the current ratio, the resistance ratio, you have to get the resistance ratio. For getting the resistance ratio, what you have to do? Resistance ratio nothing but what you will get here whenever the bridge is balanced? P by Q is exactly equals to how much? R by S. Here the current I1 is passing in the resistance P and then I2 is passing in the resistance R, and then even the I1 is only passing through the Q and then I2 only passing through the S. So that then what is the balancing condition? Nothing but this P by Q is equals to R by S. Otherwise I can say P by R is equals to Q by S. Is there any change in that? Is there any problem in that? See that I am just sending this one down and then this one up. Anything is correct only whenever the bridge is balanced. If the bridge is unbalanced, we will not use this formula only. You understand or not? So always P by Q is equals to R by S. You just take the either these two resistors, otherwise these two resistors. Everything is same only. Now this is a case of whenever the bridge is balanced. If the bridge is unbalanced, at that time what I can say? And moreover, whenever the bridge is balanced, at that time I am saying that VB is exactly equals to how much? VD. Then what I can write? The current flowing in the galvanometer is how much? Ig is equals to how much? 0. Why? Because there is no potential difference, there is no current flow. That is about the balanced condition. Unbalanced condition is important for the direction of current. In which direction current will flow is important. Now, if the bridge is unbalanced, here I am getting the difference of the potentials here. VB and then VD are not equal. Then only the bridge is unbalanced. If both are not equal means there is a potential difference. If potential difference is there means what will be there? Current flow is there. So what I can say, whenever the bridge is unbalanced, at that time VB is not equals to VD. VB is equals to VD, Ig is equals to 0. Then what I can say, bridge is balanced, then P by Q is exactly equals to R by S. Then if the bridge is unbalanced, at that time VB is not equals to VD. Both are not equal, nothing but what I can say, there is a current flow. So that what I can write here, Ig is not equals to 0. Yes, okay, Ig is not equals to 0. Now tell me, from where to where current will flow? If the current flow is there from the B to D means, what is the condition for that in terms of resistance I am asking. If the current is flowing from D to B means, what is the condition of resistance? Condition of this ratio of the resistances. What is that? What is the condition whenever the current is flowing from B to D? Let us consider. Otherwise I will give you the condition, you just tell me from where to where it will flow. Clear? So now I will tell that P by Q is less than R by S. P by Q is less than R by S. B to D. D to B. Bottom to top or top to bottom? Bottom to top. How you are saying that? Yes, see that here resistance is less. Resistance ratio is less, nothing but the entire top resistance is lesser than the bottom resistance. Here more resistance means what I can say? Current flow will be less. Current flow is less, at that time voltage will be what? Less only, voltage will be more. No. Just see that here I am saying that P and then Q is less. P and Q is less and then R and S is more. Now here there in this route there is a more resistance. More resistance, nothing but what happens? Current will be less. So what I can say here, I1 greater than I2. Is that correct? I1 will be more as, why? Because this in this route it is finding more resistance. In whichever the route you will have a very rush queue, in that queue you will not go. You will go in the queue of which is very freely. Very free, nothing but what is that? Resistance is less. So here also the resistance, the topmost resistance is less as compared to the bottommost resistance. If this is more means in this direction current flow will be less. So here more current flow is there, more current is going from here and then it is coming to the bottom. So what I can say, the current flow will be from where to where? B to D. Clear? So you just remember that here it is not free, this path is not free. This path is very much free. What is the reason? I said that topmost ratio of the resistance is less as compared to the bottommost ratio. So here the route is free and then here it is not free. So what happens? Current will flow in this only. Current is flowing in this only. So here more current will be there. Obviously it will split and then it will come to the bottom. So current flow will be from where to where? I flows from where to where? B to D. If P by Q is greater than R by S, at that time what happens? Current flow will be from where to where? D to B. Why? Because the topmost point, this route is blocked completely. This route is blocked, then what happens? Current will move freely from here to here. Whenever it is moving freely, here it will get splitted and then it will go to the top point, so that the current flow from where to where? Nothing but I flows from D to B. That is the main direction of currents in the case of the unbalanced Wheatstone bridge. Now after that, whenever they have given the unbalanced Wheatstone bridge, for example, they will give the values like this. Now let me take, they have given us 10 5 and then 5 10. Is that balanced? Is that balanced? Yeah, how to check that it is balanced or not? You have to take always P by Q is equals to R by S. Any ratio you can take. You can take either this ratio or this ratio. There is no problem in that. So 10 by 5, nothing but how much? 2. 5 by 10 is 1 by 2. Both are not equal. Now the bridge is not balanced. Whenever this bridge is not balanced, then how to solve the problem? Nothing but you have to take this one as any RG. Let me take that as given as a 5 ohms, like the 10 ohms, anything. Now what you have to do? Nothing but you have to take the entire circuit and then you have to apply the KVL here, even KVL here, even KVL here, and then you have to solve 3 equations and then you have to get the answer. Yes sir. So after solving the equation, you are here you have to find out 3 currents. One is I, another is I1, another is I2. So the 3 currents you have to find, nothing but you have to solve 4 equations. Clear? That is how you have to do in the terms of KVL. Otherwise in nodal technique it will be very easy. So here already we know that, here only I will explain that. Here voltage is V, means here also how much voltage is there? V voltage only. If this is 0 voltage, means this is also much? 0. Let me consider that at this point the voltage is VB, at this point the voltage is VD. Now I am saying that the current is flowing from I to I1 and then I2. Now at this junction, if I apply the what is that nodal method, otherwise Kirchhoff current law, then what I can say at this junction? I is equals to what I can write? I1 plus I2. For example, for this entire Wheatstone bridge, there will be a external resistance R, let us consider, otherwise R external RE. Now I can say I is nothing but what I can write? What is the I? From where to where it is flowing? I is flowing V2. At this point here resistance is there, means it will change. You are understanding or not? So here there is a resistance, means it will change here. So if you don't take the resistance, directly I is equals to what I can say? Nothing but the current is I is equals to directly V by R will take. And then after that, here I1 is flowing in between what here? V and then VB. V minus VB by resistance is how much here? P. And then this current is flowing in between what? V and then VD. So that V minus VD divided by R. Whenever you apply the Kirchhoff current law, there we will get the relation between the VA and then VB and then VD. Why? Because VA already we know that how much VA is V only, and then VC is how much? 0. We will get one of the relation between the VB and then VD. And again you have to apply the Kirchhoff current law at this point. So here current I1 is flowing and then IG is coming here, and then this I1 nothing but, now whenever the bridge is not balanced, at that time this will not be I1. You understand or not? So exactly here how much current is there, here also that much current only will come, opposite current will come. Here I1 nothing but, here also how much will come? I1 only will come whenever the bridge is not balanced. So again you have to apply the KVL here at this point. Now I1 is entering, who is leaving here? IG, and then I2 is leaving. Now I1 is in between what? V and then VB, V minus VB by P, and then I2 is in between what? VB and then 0 by Q, and then IG is in between what? VB and then VD by G we will take. That is how you have to apply the nodal methodology, and then they will not give any unbalanced conditions and all. So only balanced conditions are important. And what is the purpose of the Wheatstone bridge? To find out the unknown resistance. You have to find out the unknown resistance among these resistors. They will give one of the resistance as unknown, and then you have to find out whenever the bridge is balanced. Simply you will take it as P by Q is equals to R by S. For example, let me take, I want to get to know the S value, nothing but S is equals to what I can write? Simply RQ by P. That's it. Only this much purpose is there for the Wheatstone bridge. The Wheatstone bridge is mainly used for finding the unknown resistance value among the given resistors, and always the balanced condition is important for us. In that balanced condition, what happens means at point B and then point D there will be a equal potential. VB is exactly equals to VD. Whenever the VB is equals to VD, then what I can say? Current flowing in that is how much? 0. Whenever the current flowing in this and then the current flowing in this is 0, means there is no need to take this terminal and all. So directly only 4 resistors will be there, PQ and then RS. Whenever the bridge is balanced, at that time the ratio of these 2 resistors is equals to the ratio of these 2 resistors. Otherwise the ratio of these 2 resistors is equals to these 2 resistors. Either P by Q is equals to R by S, otherwise P by R is equals to Q by S. Anything is correct only. Okay. Now in that, any value will be unknown. You have to find out that unknown value only. So if S is unknown, nothing but S is equals to R cube by P. That is about the balanced. In case of unbalanced, current flow is important. When the current flow will be there from the B to D, nothing but wherever the resistance is less. That is what you have to remember mainly. Wherever the resistance is less, the current will flow from that point only. Here I said that P by Q is less than R by S. Here less resistance means what I can say? More current flow. The more current flow is coming into the bottom point here. That's it. Here R by S is lesser than P by Q means what I can say? There is a more current flow in I2. That I2 will go from where to where? D to B. That is about the current flow in the unbalanced case. In the unbalanced case, you have to find out the potentials, nothing but you have to apply the nodal methodology. That will be very easy. And now in the unbalanced condition, how to find out the equivalent resistance? That is important. See that here I have 5 resistances here. How to solve this equation? How to solve this circuit to get the equivalent resistance? Generally what we will do? Generally in all the always what you will do? You will remove the 5. Here current is splitting as I1 and then I2. That has to combine here, nothing but I will remove the middle 5. Actually we will do that only in the combinations of resistors. But now the bridge is not balanced, nothing but there is a current flow in this also. If there is a current flow, nothing but I will tell you one very easy shortcut method, that is add all the values and divide by the number of resistors. Any problem you take, whatever the values they might be given, that will be the deadliest easy trick. So what you have to do, nothing but you have to add all the resistance here, 10, 5, 10, 5, 5. How much totally? 35, 20 and then 20. 15, 15, 35, yes. 35 by, how many resistors are there? 1, 2, 3, 4, 5 resistors. Always 5 only. 7. 7 is the equivalent resistance there. That's it, finished. You understand or not? So always the sum of the resistance by number of resistance will never change. That is how much always? 5 only. So sum of the resistance by number of resistance. And also in some of the problems, they will even give like this also. They will add one more resistor here. Let me take, that is 5. At that time you don't add again all, okay na? You always make it as a normal Wheatstone bridge only, take it as 5 by 2, then get the answer. Clear? That is about the equivalent resistance for the unbalanced Wheatstone bridge. And first and foremost, whenever they have given the bridge, at that time you have to check that is balanced or not. So whenever you want to check, nothing but here whatever the ratio is there, here also the same ratio should be there. They might be given the middle resistor or not. First and foremost, you have to check the problem that it is balanced or not. If not balanced, nothing but whatever the method I said, sum of the resistance by number of resistance you have to do. If it is balanced, nothing but simply remove the middle one and add them in series. 10 plus 5 is 15, 10 plus 5 is 15, 15, 15 in parallel. So how much answer? 15 by 2, 7.5 is the answer whenever the bridge is balanced. Whenever the bridge is unbalanced, at that time what is the answer we got? Just 7 only we got. Sum of the resistance by number of resistance. Clear? I understand, right? Yes, right there, Wheatstone bridge. Did you draw the diagram? Huh? ಅರ್ಥ ಇಲ್ಲ. ಈ ನೋಡಲ್ ಮೆಥಡಾಲಜಿಲಿಂದ ಬರುತ್ತಲ್ಲ, ಪೊಟೆನ್ಷಿಯಲ್ ಬಂತಂದರೆ whenever they have you find the VB and then VD by using the nodal method. Then Ig is equals to, what is the formula I can write? Ig is equals to VB minus VD by galvanometer resistance is how much? G. That's it. Understand? Yatish. I value, I formula is what? Potential difference by resistance only, right? Potential difference nothing but what is the potential difference here at point B and then point D? You have to apply the nodal method. By nodal method you will get the VB and then VD value. What is the VA, VC values? VA is equals to how much? Just V, VC is how much? 0. So only unknown values are here, VB and then VD. You have to find out the VB and VD. If you are not applying the nodal method here, you just apply here only. You just apply here and then apply here only. You will get the relation, just potential difference. You will not get the VB, VD values directly. You will get the VB minus VD, otherwise VD minus VB. So by that you can get the current directly. Ig is equals to. Clear? I will explain you that if you want. Right, first of all, Vishnu Bridge, draw the diagram. Draw the diagram, indicate everything properly. What is that UB there? Unbalanced. ನಾನು UB ಬರೆದಿದ್ದೇನೆ, ನೀವು ಕೂಡ UB ಬರೀಬಾರ್ದು. Are you okay, Firdaus? Yes. Yesterday physics class taken for you? No. Section B na? ಮೊನ್ನೆ ಕೂಡ ನಿಮಗೆ ತಗೊಂಡಿದ್ರಲ್ಲ. ಓಕೆ ಓಕೆ. Kishore sir has taken, huh? Clear, huh? See that the bridge is unbalanced and then asking for the IG. People are asking that doubt. See that if the bridge is unbalanced and then there are unbalanced nothing but what will be there, IG is not equals to 0. Then IG is equals to how much? If they have asked like that, then you have to apply the junction law at point B and then point D. Any points you can apply. Why? Because here I don't know the resistance. Instead of that, I will apply at point B and then at point D. At point B, who is entering here? I1 is entering. Who is leaving? No. This one is this is I1 nothing but this will be another current, right? So if the bridge is balanced at that time, same I1 will be there. Now let me make this is I1 and then this is I2, this is I3 and then this is I4. Like that it is there. Now here in this, mainly whenever you take the unbalanced case, at that time here whatever the current is there, here also the same current will come, opposite arms. So here I2 is there, means here also how much it is? I2 only. This is I1 means this is also how much? I1 only. That will be the condition for the unbalanced. What is the reason means? I said already, whenever the P by Q is less, P by Q is less than R by S, at that time what happens? Current will flow from where to where? B to D, right? So at B, what the current is entering here? I1 is entering, that part of the I1 will come here and then it will go here, B to D. And then whenever the R by S is less than the P by Q, then what happens? Current will flow from where to where? D to B. So that in D, from D, what is coming here at D? I2 will come and then it will go here. So that is about the currents in the opposite arms will be same whenever the bridge is unbalanced. Now the thing is, you have to find out the current Ig means, first of all you have to apply the nodal methodology for the point B and then point D. Now here the potential is V means this is also how much here? V only. This is 0 means this is also how much? 0 only. Now I have VA is equals to V and then VC is equals to how much? 0. VB is equals to, let me take the VB and then here VD. Now at point B, you are applying the junction rule. Junction rule nothing but currents entering is equals to currents leaving. Who is entering here? I1 is entering. I1 is entering. Who is leaving? I2 plus IG is leaving. These two are leaving. Now I1 is in between what? V and then VB. So that V minus VB by resistance is how much here? P. Then I2 is nothing but I2 is in between what here? B and then 0. So that is VB minus 0. That divided by how much resistance is there? Q resistance. Then IG in between what here? B and D. So that VB minus VD divided by G. Everything is correct. Now here they will give the resistance values. Let me take that only. I have taken 10 5 example, right? This is a 10 5 and then this is 5 10 nothing but. At that time what I can say here, P is nothing but 5, Q is how much? Q is also 5 only, and then G is how much? G is, let me take that is also 5 only, so I have taken 5. P10, yes, P10. Then what happens here? Everything gets cancelled. Then V minus VB is equals to 2VB plus VB minus VD. Then what happens here? 2VB, 2VD. Then what happens here? 4, 5, 5VB and then minus 2VD is equals to what we are getting here? V you are getting. That is the potential difference between the VB and then VD. Now voltage value they will give, of course, let me take this as a 20 volts battery. At that time what I am saying, what I am getting here? 5VB minus 2VD is equals to 20 volts. Now we got the potential difference. I want to find out the Ig means Ig formula is what here? Ig is equals to what I can say? VB minus VD by how much galvanometer resistance is there? 5. VB minus VD value substitute here and then get the Ig value, that's it. Clear? You understand, right, how to solve this? So unbalanced condition, otherwise balanced condition. In an unbalanced condition, if they are asking the equivalent resistance means what you have to do? Sum of the resistance by number of resistance. Yes, sir. In the unbalanced condition, if they are asking for the equivalent resistance, then what you have to take? Nothing but sum of the resistances by number of resistance you have to do. Whenever they are asking the potential difference, directly you can do from here to here and then you can leave it. And then whenever they are asking the Ig value, at that time again you have to do Ig is equals to VB minus VD by G, whatever the value they have given. Clear? That is how you have to solve in the case of unbalanced bridge. That will not given, so always balanced condition only will be given. Clear? Then write a problem. Have you written the shortcut point? How to get the equivalent resistance? Write that. In unbalanced condition, to get the equivalent resistance, in unbalanced condition, to get the equivalent resistance, just write R equivalent is equals to sum of all resistors divided by number of resistors, that is 5 in bracket 5. In the next line, to calculate the current in the galvanometer, apply the nodal methodology and find the potential difference between B and D. That's it. Solve this problem. RAB is how much? What is RAB? How much? R by? Yes, R only. See, whenever any problem, if you find in any structure, that might be the structure might be anything, there is no need to that, always this will be in the square form only. That might be in any form, you just count the number of resistors. If 5 are there means blindly that is a Wheatstone bridge only. Clear? Here the structure might be anything 1, 2, 3, 4, 5. So that 2 resistors are connected and then 2 resistors are connected, in between them 1 resistor is there. So of course which is that one is Wheatstone bridge only. So what I can say in the Wheatstone bridge, P by Q is exactly equals to how much? R by S. Both are balanced. So that what I can say, I can remove the middle one. I can remove the middle one. This is a balanced Wheatstone bridge. So what is the answer you will get? At the top, what is the resistance you will get? 2R. At the bottom, how much you will get? 2R only. Then equivalent will be how much here? 2R by 2. That will be how much? R. That is the answer. Clear? Now get the answer. What is the answer? R only again. So now tell me, I will give you the numbers, which resistors should be removed here. Which one should be removed? What is the answer first of all? R is the answer, right? Which one? That is Wheatstone bridge only. How I am saying that as a Wheatstone bridge? It is not in the shape of that, right? Actually, what I can do? I will just lift this point A. I will just lift this point A and then I will keep here. Then how it will be? In the Wheatstone bridge shape only, right? I will just lift this point A and then I will keep here. I will just lift this one here and then I will just keep here. Then my circuit will become like this. The circuit, the new circuit, whenever I lifted this one here to here, at that time it will become like this. Correct? Huh? Then B will come here. B will come here and now this is gone in middle. Now this is what? Wheatstone bridge only, of course. So which should be removed here? R4 has to be removed so that I can get again what is the answer here? R only. Clear? Have you drawn the first diagram first? Draw that if you might be not drawn that. This is the first diagram. After that, equivalent circuit is that. Yes. Which one we have to remove here? Which is common for both the terms? Second one, right? So if the resistors are not there, here resistors are not there. At that time we discussed about the short circuit. Yes, do you remember that equivalent circuit? So whenever the resistance is not there, here potential is same and then this one also same. This one is same only here. So in the middle one, what is the current flow? Nothing but there will be a zero current flow. I said that one in the short circuit problems. Now here what happening, nothing but this is simply, I'll just pull this one down, I'll just pull it up, that's it, our circuit is finished. What I'm doing, nothing but this point is there, no, I just pull it down and then I'll just pull it up. Then what happens, it will be again Wheatstone bridge only. So here this 2 is exactly equals to the middle one, galvanometer resistance. So what I can do, nothing but I can remove this one. If the bridge is balanced or not, how to check that is nothing but again this is R, everything is R only here. So P by Q is equals to what I can write, just R by S. Then bridge is balanced, then second resistor can be removed. Then what is the net resistance now? Net resistance is again how much? R only, right? So here the equivalent circuit will become like this. Equivalent circuit after removing of second resistance, it will be there like this. Now these two are in which combination? Series. Again these two are in series, everything is in parallel. So what is the net resistance here? R equivalent is equals to how much? R only. Clear? This type of questions can be asked in the Wheatstone bridge problems. Now next problem. Now do this problem. Get RAC. RAC. Try to redraw the circuit first. Water bottle. Shamantak Mani. Uday. Water bottle. R by 2 na. How you said that? You just redraw the circuit in terms of Wheatstone bridge, how it can be formed in the Wheatstone bridge. R. Any other answer? Yan Manu, nide marta idra? You are not listening in the class. Today something happened to you. Something. There is a something. Your first in the yellow idaru class kelta illa. Yar nenap marta idru? What's the answer you got? R is answer. Then any other answer? R square, R cube, R by 2. How many of you are? Neutral should not be there. You have to raise any one answer. R. Okay. Then R by 2. Remaining people are uncharged bodies. Both charged bodies. Answer is R by 2. R by 2 is the correct answer. I will draw you the redraw the circuit here. So whenever you see here, you just select the five resistors which are symmetric. Which are symmetric here? Which part is symmetric? Nothing but which part can form the Wheatstone bridge by using the 5 resistors. This one, right? Upper one. Upper one can form 1, 2, 3, 4, 5 are there. 2 are connected, in between 1 is there. So I can say that this is a Wheatstone bridge. Otherwise, if I take this one as a constant, again this is also a Wheatstone bridge only. If I take this one as a constant, this is also Wheatstone bridge only. Yes, you can form in any way. So that I am asking here RAC only. For that purpose, what I will do, nothing but I will just redraw the circuit like this. Now, let me give the numbers 1, 2, 3, 4, 5, 6. Check that. Here this is 1, 2, 3, 4, 5 and then 6. Is that correct? Is that correct? See that? 1, 2 combined at point A. Let me take this is a point A, this is point B. At point A, 1 and then 4 are combined. 1 and 4 are combined. And in between them, what is there? 5 is there. 2, 3 are combined at which point here? Point C. So that here, point C. At point A, 1, 4 combined, in between them 5 is there, 2, 3 is combined to point C. Finished. Then last one, 6th resistance is coming here. One of the terminal of the 6th resistance is connected to what? Point A here. Another terminal is connected to point C. So that only A1 connection, C1 connection gone. Finished. Now, if you check this one, everything is R only. So the bridge is balanced, so that 5th one remove. Then what is the answer here? How much will be there? R by 2, R by, this one 2R, nothing but what I can say, this one is R. And R are in parallel, nothing but what I can say, R by 2 is the answer. Clear? So that RAC is exactly equals to, here what will get, nothing but at the topmost R will get for the entire Wheatstone bridge, and after that bottom also how much is there? R. Then how much will get equivalent is R by 2. You understand or not? So that is how you have to redraw the circuit. They might be asked about the BC also. BC also same or different again? Same only. Whenever I say BC, which resistors are Wheatstone bridge resistors? See that I am giving the numbers here 1, 5, 4, 3, 6, 2. I am saying to find out RBC. At that time, which are the Wheatstone bridge resistors? 1, 4, 5, 6, 1, 4, 5, 6 and then 3. Which is the middle one here, galvanometer? 4 is the middle one. Then you have to remove the 4. If I say RAB, at that time, which are the Wheatstone bridge resistors? 2, 3, 6, 4, 5. Which one is the galvanometer here? 3 is the galvanometer, so that you have to remove that one and then you have to get the same answer again. Clear? So, you have to first of all take the Wheatstone bridge shape. So, wherever 5 resistors are present, in that 5 resistance you check that side 2 should be there, this side 2 should be there, in between 1 should be there. So which one can be formed like that? Nothing but here this many resistors I can take and then I can form a Wheatstone bridge. Here this 1, 4 are connected to A, 1, 4 connected to A, 2, 3 connected to C, 2, 3 also connected to C. In between them what is there here? 5. So that 5 I have connected here. Then again in between AC what is there here? 6th resistor. So that 6th resistor is kept between A and C. And then now this is the balanced Wheatstone bridge, so that I have removed the 5th resistor. Then this is how much here? 2R. This is also how much? 2R. 2R and then 2R. How much it is? R. And then R and then R. How much it is? R by 2. That is what the answer we got. Clear? These and all are important in the case of Wheatstone bridge problems. Right. Next one is meter bridge. Next concept, meter bridge. For weekend exam, syllabus is up to here, up to the Wheatstone bridge. Then next meter bridge. And before that, I will give you one small problem. Now tell me, what is the equivalent resistance? Is that balanced? It's not balanced. So you have to tell me the equivalent resistance. 4. How you got that? Sum of the resistance by number of resistance. 3, 4 is 7, 5, 6 is 11, 18. 18 plus 2 is 20, 20 by 5 is 4. Finished. Even write this example also. Find the equivalent resistance. R equivalent 3 plus 4 plus 5 plus 6 plus 2 divided by 5. Then answer is 4. 4 ohms is the resistance. Finished, huh? And also theoretically there is a chance for the one problem in this Wheatstone bridge, that is, before whenever I drawn the Wheatstone bridge, initial Wheatstone bridge PQ and then RS, I have taken here, and then here what we have taken, battery, right? And then in between what we have taken, galvanometer. This is the actual structure of the Wheatstone bridge, and then if it is balanced, then Ig becomes how much? 0. Now here the bridge is balanced. Bridge is balanced here. Whenever the bridge is balanced, at that time what I am doing, nothing but I am just interchanging the galvanometer and then battery here. I will just put the galvanometer here and then I will put the battery here. Then balancing condition will be there or it will not be there. Observe properly what I am doing here, and then just in the mind only you just rearrange the circuit and then tell me. Balancing point will be there or not there? Bridge is balanced or not? First of all tell me. Is it balances? How it will balance? Yes, you just take this away. Take this one here. Take this one in between. That's it. Finished. Right? No, the bridge was there before like this, now I am just doing like this. That's it, finished. You understand? Just we are tilting that, we are just pushing that and then it is becoming like that. It is just tilting. You are understanding or not? So that at that time actually what was there, points before A, B, C, D like this we have taken. Galvanometer was there in between what first before? B and D. Now galvanometer is there in between A and C. And then battery is there in between B and D. Everything is same. Just points are changing, Girish. Yes, points are changing, Girish. What points are changing here? Nityadalli 180 out of 180 in physics, dream banta. Huh? Are you there, Girish? Yes, you are there but you are sleeping. And then see, somebody is sleeping nothing but they will bend like this and then they will sleep. He is sitting like this and then in sleeping also that much stiffness. Gautam also will sleep like that only. No, he will fall only directly without consciousness, he will fall. And Samantha Kamani sleeping is very, very nice. Whenever he feels sleep, no, just he will put like this and then he will be moving the body. And then he will move the eyebrows like anything. I am not able, even he will not able to control. Ayo, one member will be there, different kind of sleeping methodology will be there here. Uday Nityadalli kuda problem ಮಾಡ್ತಾ ಇರ್ತಾರೆ. He will be sleeping and then he will tell the answer also. Medhavi. Paramananda Yashishya. So here, and this one is important point. Whenever the battery and then galvanometer are interchanged, at that time also the bridge will be balanced only. It will not become unbalanced, it will be just balanced only. But the galvanometer is between A and C and then battery is in between B and D. That's it. At that time you have to find out the Ig, nothing but what you have to take, VA minus VC divided by G you have to take. That is how you can find out the Ig value. Clear? Write that as a note point. Write that as a note point. In the balanced Wheatstone bridge, If galvanometer and battery interchanged with each other, then also bridge will be balanced. At this case, which potentials are equal whenever the bridge is balanced? At this case, what is that? Before VB is equals to VD was there, right? Now galvanometer is there in between what? A and C. So what I can say? VA is equals to VC, so that there is no current flow in this. Clear? Write that. And VA is equals to VC. At this condition, VA is equals to VC. Draw the diagram at side. So here, this is a meter bridge. Meter bridge wire is how much long? 1 meter, or we will take always as 100 centimeter. A wire is of 100 centimeters length. 100 centimeters length. Now here in this left side arm, meter bridge nothing but 3 arms will be there. In this arm an unknown resistance will be there. That is a known resistance. Sometimes they will give it as a resistance box. What is the resistance box means? Resistance kept in the box is resistance box. Of course, that is correct only. Resistance kept in the box is resistance box. What happens means, in that not only one resistor, there will be number of resistors will be placed in one box only. Whenever we just turn that as 100 ohms, then 100 ohms resistance will come. You are understanding or not? That is a variable resistance. That's it. Resistance box. This one is a known value. This one is a unknown value that you have to find out. Now here there is a galvanometer. In that galvanometer, what will be there for us? Current measure. Will measure the current. Now here what I will do, nothing but this is known as a jockey. We know only one jockey. Yes, only one jockey we know. This is other jockey. That is not that jockey. So an idea bartala? Jockey, Nike. So here, so this jockey will be moved from here to here. Now whenever I am moving here one known resistance is there, here one unknown resistance is there. So in between them a jockey is connected here, and then between that galvanometer is there. That jockey I am just moving on this meter bridge wire. Whenever I am moving here slightly like this, at some point of time I am observing this one. Galvanometer I am observing, I am just moving this jockey here. Now whenever I observe, at that time it is fluctuating. Nothing but it is showing the current I. Now what happens means, somewhere I gone here. At this point exactly I got I is equals to 0. Nothing but the galvanometer, the current became like this. Exactly at the 0 only. It is not coming to the right side or not coming to the left side. So this is a 0 point. 0 nothing but what I can say? Current is 0 nothing but bridge is balanced again. Now let me take, this is a wire of length L, and then its resistance is P. And then this remaining wire will be how much here? 100 is total, then remaining length is 100 minus L, and the resistance is Q, let us consider. Now also what I can say, whenever the bridge is balanced, P by Q is equals to exactly R by S. So P by Q is nothing but how much is there here? P by R is there. that is equals to R by S, nothing but here Q divided by S is there. Now here P is nothing but what I can say, length L. Why? Because R is directly proportional to L always. What is the resistance? Resistance is directly proportional to L and inversely proportional to area. By the way, area is same only, uniform wire and also of same metal, so that resistivity also same. If R is equals to rho L by A, I said that area is same and then resistivity also same only. Then what I can say, R1 by R2 is equals to L1 by L2. So in the same way here, P means what I can write, L divided by resistance value is how much, R, that is equals to, Q means how much here, 100 minus L, that divided by S, which is the unknown resistance here. S is the unknown resistance, so that S is equals to what I can write, R into 100 minus L by L. That's it, finished. This is the way to find out the unknown resistance. The Wheatstone bridge will be, the Wheatstone bridge even then meter bridge, both will be used to find out the unknown resistance only. But in that will not move anything, it will only will be moving and then it will give the zero current there. Now in this what happens means, we have to make fluctuations in the galvanometer, nothing but you have to move the jockey along the meter bridge wire. We have to touch it and then we have to just move it. So whenever I am touching and then I am moving, here I am finding so many fluctuations. Sometimes it is coming as 10 milliamperes, otherwise 5 milliamperes, like that. At some point of time, exactly at this point of time, my galvanometer is showing zero current. Zero current in the galvanometer means what I can say, the bridge is balanced, then P by Q is exactly equals to R by S. Here RB is the known resistance value and S is the unknown resistance value. Now if you observe that clearly, this is one resistor, two resistor, 3, 4 and then in between another resistor. This is again which circuit this is? Wheatstone bridge only. So P by Q is exactly equals to R by S here. Now here this length of the wire is L. If I consider at L length, the bridge is balanced, nothing but the remaining length will be how much here? 100 minus L. So that L by R is exactly equals to 100 minus L by S. That S value only I have to find out. To find out that S value, S is equals to R into 100 minus L by L. Otherwise, they will give this length value directly. Some of the times they will give the ratio also. At what ratio of the length it is becoming balanced, nothing but, for example, at 25% of the length it is balanced, nothing but at what point it is balancing? At 25% of the length, the bridge is balanced, nothing but it is balancing at L by 4. 25% nothing but of which one? L by 4 only, right? 50% nothing but what is L by 2, 30% nothing but L by 3, like that. Not even L by 3, it will be less than that. So in the percentage also, so some of the times they will give the problem, so that always you don't expect that directly L means 20 centimeters, 30 centimeters, like that they will give. It might be given in the percentages or it might be given in the ratio, 1/4 of the length, 2/4 of the total length, like that also they might be give. So anyhow they might be give, but you have to take this formula only. S is equals to R into 100 minus L by L. Here left gap is known resistance, right gap is unknown resistance. And some of the times in any one problem they will give the unknown value and then they will ask the known value also. Nothing but right gap value they will give and then they will ask the left gap value. And also one more possibility is there. Here they will connect as shunt resistance. What is a shunt resistance means? Parallel resistance. Whenever I connect any resistance in parallel, that I can say as a shunt resistance. So for the S, if I connect any other resistance, then it is balancing, like that they will tell. So at that time what you have to take here, R1 R2 by R1 plus R2 is the right side resistance, left side resistance is what exactly? R only, and then we can get the answer in the same way again. You understand how many problems are possible? That is what I am saying. First one is directly they will give that L is, bridge is balanced at exactly 10 centimeters. So there is no doubt in that. You have to use this formula and then get the unknown value. And always I am not saying that always right side is unknown. Sometimes they will ask to find out the left side value also. Otherwise they'll ask to find out the length also. They'll give all these values and then they'll ask the L value. Clear? So there is a chance for that kind of problems also. Another kind of problems is they will give the percentage of length. 70% of the, at 70% of length the bridge is balanced. At that time you have to take 70 by 100 of L you have to take. That is a balancing length you have to take, and then you have to find out the answer. And also one more condition is, they might be connect some of the resistors in shunt. Shunt nothing but parallel to either S otherwise R, and then you have to find out the remaining values. So this many number of problems possibilities are there. Clear? Right, that meter bridge used for finding unknown resistance. Used for finding unknown resistance. Used for finding unknown resistance. In the left arm, known resistance R, known resistance capital R, or resistance box, and in the right side arm, unknown resistance will be connected in the next line. When the jockey connected to the galvanometer, will be moved on the meter bridge wire of 100 centimeters. At the point where galvanometer shows null deflection, that length from the left side of the wire, is balancing length. And the remaining length is 100 minus L. Copy that. ఏమో నిన్న ఏదో రోగం వచ్చిందంట నీకు, ఏమైంది? ఫినిష్డా? Write a problem. The resistance in the left arm is 110 ohms. Resistance in the left arm is 100 ohms. 100 or 110? And the distance of null point from point B, A to B is left to right, and then B to A is right to left. Okay, from point B is 45 centimeters. is 45 centimeters. Then find the value of S. How much? Very good. Very good. 90 is the correct answer. What's the S value? Yes. 90 is the correct answer. Yes, sir. You got that 90? From where I am giving the length, you have to identify mainly. I said from B to A. 90 is the correct answer. If you are not getting the answer, means the answer is you are not doing the problem. That's it. How many of you got that 90? What about the remaining people? You are not reading the question. From where I said balancing length? B to A. B to A nothing but from the right side how much length I said? 45. Nothing but I have given the 100 minus L value. Then L is how much here? 55 is the L. You are understanding or not? I said from point B. From point B means from point B to balancing point how much length is here? 100 minus L. That 100 minus L is 45, I said 45 centimeters. Then L is of course how much? 55. L is 55. Now find the answer. S is equals to R into 100 minus L by L is the formula for us. Then R is how much? I said 110, I guess. 100 minus L value is how much? 45. And then L value is how much? 55 here. And this will be how much here? 11, 9 by 11. Then this is tens. Then this will be how much? 90 ohms is the correct answer. That's it. Why you are not doing that? Whoever are doing that as wrong, you might be considered that as point A to B. You might be taken L as 45, 100 minus L as 55. And then you got the wrong answer. What is the answer you got then? If you take in that case, what is the answer you got? How much you will get? 55 by 45, you will get 90 by 110, like that you will get. Then next problem. In the given diagram means whatever the diagram we have drawn. In the given diagram, R is to S is 1:4. R is to S is 1:4. And distance of null point from A is L1. Full stop. If R and S are interchanged, then distance of null point from A is L2. Distance of null point from A is L2. Then find L2 minus L1. Then find L2 minus L1. Before R is to S I have taken 1:4. After that I just interchange them. Nothing but initially R and S was there here only. Now S is coming here and then R is going here. Initially balancing point is how much I said? L1. Later on balancing point is L2. Then you have to find out the L2 minus L1. चलो take the break. Lunch off जाना है वीडियो.